Hi. Hi there. Sorry for the delay. We can start. Thank you. So we have about 40 plus presentations. We have, well, let's say 2 hours. So we can make it in 3 minutes, but it has to be super fast switching, etc. I will do my best, but I know I'm for sure mess up sometimes. So the shorter the better. So everything between 2 and 3 minutes is super. I like to give you, Frank, to kick off and give a short presentation in memory of Dave. Thank you.
Hey guys,
Please, can everybody be quiet? Everybody, quiet, please. Thank you.
thanks for having me. My name is Frank. I was working with Dave Tacht for last couple of years. Many of you know him, but there are some people that are new to IETF as I am. And I would like to present just a few things from Dave's life and work inside of IETF and outside. And I was told that there will be more about Dave and his contribution to the world of internet presented at the plenary on Wednesday, if I remember correctly. So Dave sadly passed away in April of this year, but his work is with us in Linux, OpenWRT, installing in many devices out there. So, so this is the part of Dave's work inside of IETF. Like he was not exactly the RFC person, but he was contributing to some of them, and notably FQ Cordel as an RFC 8290 and Cake Common Application Cap Enhanced. It doesn't have RFC yet, but I would do my best to get it in to IETF because there are some improvements to Cake in works already. Dave was also doing things outside of IETF, notably his IPv6 work, and also like he was fighting. FCC in the US to allow people to actually flash their own routers with third-party firmware, for example, like OpenWRT or DDVRT. And it was a really important fight. We also nominated Dave to Jonathan B. Postel Service Award, and we are really happy that one and only WinServe was the nominal nominator. And yeah, more at the plenary. And I'm planning to hold an informal wake for Dave in El Escorial room on Monday at 7 p.m. And last but not least, I have a scrapbook with Dave's pictures, always with me. So feel free to stand, to meet me, and if you want to share something with Dave's friends and family. Thank you very much.
Thank you, Frank. Okay, thank you. The next regular presentation is SIMAP, Hackathon presentation. And after that will be the the next one after that is interface to network, computing. I should put on my reading glasses. There we go.
Next one is this, is it? So hello everyone. I'll try in 2 minutes to present the intro into the SIMAP Hackathon. So this was the original plan. We started in IETF 1.1 and we were focusing on ISIS and then some prototype for adding external references. Then on IETF 122 hackathon, we explored different options for adding external references from topology, and then started modeling SIV6 for topology as well. And if you are interested, there is a draft that Vivek is the main author for draft Vivek SIMAP extension, external relationship, and template design is proposed there. And in this hackathon, we are supporting this draft. We implemented the POC for this draft, and we also added VPN services transported via SIV6 based on previous modeling effort around RFCA 345 approach and extending it for CMAP. This is examples of our old labs. We use Swisscom and Telefonica lab in previous hackathons, and now we extended with new labs, another Swisscom lab and virtual lab. So this is example of one of our topologies for SIV6, where we are showing segment lists, candidate paths, and policies tunnels are not included. This is our achievements, linking topology entities to external model data. We had a consensus reached on templates based on the interim meeting we had around the topic on NMOP, and it's implemented currently in the library, and we rely on templates to query information about layer 3 operational state of the interface and ISIS LSP timer configuration. We added SIV6 modeling for segment list, candidate paths policy, and service layer 3 VPN over SIV6 as well. And what next? Feedback to NMOP. We are presenting on Monday, we are presenting the drafts, and on Wednesday, we are presenting the hackathon. Vivek will present the NMOP or Pierre, and we want to get feedback on the SIV6 models that we are proposing. It would be very important for us to get feedbacks from anyone here or on the mailing lists. We are usually on NMOP mailing list. And we want to do support steering of SIV6 layer 3 VPN services over SIV6 policy driven paths. And also at CMAP, we are now proposing to move to the modeling phase as well. So we want this hackathon to continue evolving to be fully aligned with CMAP drafts. And this is the draft that we started 0.0 version on the modeling. Thank you.
Thank you. So up next, interface to network computing or in networking computing, and after that it's the NASR proof of concept. There you go. You can use
Hello, my name is Moseku from Songyungan University, located in Korea. I'm going to present about our project, interface to in-network computing function project for this Hackathon 123. This is the poster of our project. I'd like to introduce our framework that enables autonomous vehicle to be controlled and managed through natural language intent commands. This framework encapsulates the full process from natural languages, intent parsing to autonomous execution and monitoring for closed-loop purpose. Since we've done this project in previous hackathon, I'd like to highlight the key differences between the previous one, and the current one. The previous was mainly focused on intent translation and provisioning itself, but this time we focused on the monitoring interfaces and collecting data to be analyzed. As you see on the screen, the translated policy from user intent is forwarded to the wireless network component to be sent to moving object controllers. Okay. In our current project, we extended this work. So through the iterative development, we are building we collect the data from the moving object and we deliver it to the servers so the user can monitor and analyze for further procedure. This is the goal of our hackathon. Our project aims to realize user intent-based controls of 3 categories of actions, which is going to be the categories of actions of moving object behaviors, which is our sensing, moving, and actuation. The underlying the components that are what we achieved. So we use the camera sensor and the odometry sensor to be collected. For the movement, we implemented the 4-wheel movement and actuation. The sensing data delivery, we've done this over, and yet the component those are not underlined is our target for the next hackathon. This is a flow of our project. Oh, I think it's running out of time. So we collect the data from the rover car and deliver it to the edge server, and we convert them. To the find data. We perform the object detection and send it to the cloud server, so the user can monitor and analyze. So these are the demonstrations, and so this is what we learned. And for the next steps, we're gonna enhance it. And this is the GitHub. You can follow up. And these are the demo videos. And this is the hackathon team. And our side meetings held on this coming Wednesday at 2 small room. Thank you.
Thank you very much.
Yeah.
Thanks. So up is NASR, and after that is Mouseworld. Does this work? It works. Yeah.
Hi, I'm Michael.
Yeah, Michael. Yeah.
I should do this. Yeah. Okay. I'll talk into the microphone. Where's the pink square? No pink square. So I'm here to talk about the NASR proof of concept that I've been working on. NASR is network attestation for secure forwarding. It was secure routing, but we changed it. We had a BOF in Bangkok. That was our second one. It was not well received. Really, we put rough consensus before running code. So I'm here to advance the state of running code, and perhaps we'll be able to do something again in the future. There's a bunch of requirements. You can go back to the BOF recording if you want to know more. And the previous BOF was Vancouver, I think, the year before. So what do we do? So we test equipment. We basically build a minimal network that had at least 2 paths through it, such that one path could be the one we want, and one path could be the one we don't want. And you can see we've nicely color-coded all the cables so you can unplug them and, cause rerouting and all the resiliency that we care about on the internet. And the machines are named after those Disney ducks, and Della is apparently their mother for that. So what are we working on? So we have a bunch of layers. Some of you may own the Evie Nemeth t-shirt with the 9 layers of the internet, and you are here at the top. And so we're trying to move our way up the layers. Our goal is to invent as few things as possible. And so you see a number of other protocols. We have 2 layers of remote attestation, one at the platform level and one at the ISP level. So if you call your ISP and say, please give me a route from point A to point B with these characteristics, and they say, yes, I've done that, well, you may actually need some assurance that they really did do that and aren't just saying, smiling and nodding and of course I'll forward your packets by whatever means possible. So that's the kind of list of things. We don't have time to talk about all of them. I just want to highlight a couple of things. There's a bunch of to be determineds. One of them is an interface from the end customer to one or more ISPs on the way. And what will that be? That's a good question. And there are other people trying to build host to network APIs with trustworthiness and other things like this. And this is a much more limited scope concept. And one possibility is maybe I2RS, but I don't know. Come and tell me why I'm wrong and what we should use instead. I would love that. That would be fantastic. So a bunch of things, SRv6 to do the path, create the path, OSPF to collect the topology, Anima ACP as the fabric for the SDN control messages and things like that. And there's lots of problems. So we're 4 layers up and we have many to go. And what are we going to be doing next time? Better orchestration. If you have a favorite orchestrator that does something and it's available, open source, or I can get a demo license, please tell me. And if you want more information, join one of the mailing lists or contact us. Thanks.
Thank you, Michael. So up next, Mouseworld, and after that, we'll have DetNet from the DetNet team. Mouseworld. There you go. Confirm.
Can you pass the slides with the arrows or also with the arrows? Oh, yeah, thank you. Okay, thank you. Hi, everyone. So this is Nacho from Telefonica, and also with my colleague Jenny. We are bringing today the Mouseworld. So what's a Mouseworld? This is a framework for network digital twins where the twin network emulates the real network in a containerized environment, specifically on Kubernetes. So our approach here is that to create this twin network, we are using knowledge graph to create the twin network. And in this case, what do we need? First, we need a topology descriptor that we will discover from the real network by collecting data, in this case from OpenStack, which is where we have deployed the network. And also, we will generate the configuration files that we need for the routers in the twin network. So how do we achieve this? Well, first step is what we call the semantic lifting. In this step, what we do is we implement a set of data pipelines where we first ingest the data from the sources, in this case, the OpenStack APIs, such as Nova, Neutron. Based on the data that we collect, we transform this raw data into RDF, and we do this by mapping the raw data to the concepts that we have defined in a target ontology, the Mouseworld ontology in this case. And finally, we load the RDF data into a knowledge graph database. In this case, we have used GraphDB. And we have implemented these data pipelines with Apache Camel and Chimera, which are open source tools. So at this point, we have integrated the data from this set of data sources in a knowledge graph. And the next step is from this integrated version of our data in the knowledge graph, what we do now is we retrieve those subsets of data that we need for creating our twin network. So here again, we implement a set of data pipelines that first retrieve this data from the knowledge graph, then transform the RDF data into what the consumer expects. In this case, the YAML descriptor for the twin network and also the configuration files for the FRR routers that we used. And finally, we'll deliver this to the consumers, in this case, as files. Again, using Apache Camel and Chimera for the implementation of the pipelines. And finally, what we achieve on the next steps, we have showed the benefits of knowledge graphs in 2 aspects. One, integration of the data. I've shown how we can integrate data from multiple sources, and also data interoperability. We have generated descriptors and configuration files from OpenStack APIs. We are planning to extend this use case with new aspects like static routes or SPS configuration. And finally, on Tuesday, the newly created Knowledge Graph Design team is having a side meeting. So you are welcome to join us on Tuesday. Thank you.
Thank you. Thanks. So up next is the DetNet, and after that it's, let's see, the young provenance. Is DetNet here or remote? Ah, excellent. There you are. Yeah, you can do it with the arrows or this one.
Oh, yeah.
Both work. Yeah.
Okay.
Well, hi everyone. We are Marta Blanco from Telefonica and David Rico from UC3M, and we are here to present the work of the deterministic networking team in this IETF hackathon. The baseline of our work is these two European projects, that is Desire6G, whose aim is to achieve determinism through network programmability, and PredictCG, whose aim is to achieve this same determinism and time sensitiveness end-to-end across multiple technological domains. So for the first challenge, we have this REST API for DetNet Intelligent on-the-fly configurator. Actually, during the lifespan of PredictCG, we built an IETF standard compliant implementation, software implementation of DetNet that can run on any Linux machine and was a key part of the PredictCG solution for multi-domain. But it has one main issue, that is that the configuration was completely static, meaning that every time that a service arrives to the network, we have to reboot all the DetNet routers or flash the configuration manually to them. So trust me, we got really tired of doing that after the 10th time. So in order to fix this, we came up with this idea for this hackathon, that we build an intelligent entity that will have a look at the topology, at the characteristic of the topology, such as the bandwidth, latency, reliability of the link, as well as the services on the network and the services arriving to the network, as well as the own DetNet capabilities such as pre-auth. And taking into account all of those, we'll came up with a suitable solution that allows all the services to to achieve their restrictions, and it will take this configuration and send it to each of the nodes and configure those nodes through an API REST that we also build in this hackathon and that we aim to present in the networking group and hopefully get to a draft of a future control plane for DetNet.
Okay, for the second challenge, we implement a wireshark detector for the DetNet packets that are operating with inbound telemetry. Inbound telemetry is a technique to observe the different metrics for the data plane. So thanks to this hackathon, we have a really great base of a wireshark detector for DetNet inbound telemetry packets with the help of AI agent. So this is a proof of the potential of leveraging AI for the future implementation of wireshark detectors for the new protocols. So that's all, and thank you very much.
Thank you very much. Thanks a lot. So up next, the Yang provisioning. And after Yang provisioning is that's the remote, the IETF post-quantum from Logodon. There we go. Again. There you go. Yeah, you can use the clicker.
Where?
Either the clicker or
Hi, I'm Ana Mendez from Telefonica, and I'm going to present our updates in applying Yang provenance signatures draft that we have in the IPsec working group. One of the first updates that we have since Bangkok presentation is adding some type of initial use cases to work with these signatures that and verification signatures that we are working with, and what we brought is based on the demo that we demonstrated in Bangkok. We aligned it with the working group that adopted draft that we have, and also with the microservices that we have for a simple verification and playing with signatures and the validation of these signatures in serverless functions. We also bring an integration with a message broker, which is Kafka. And what we want to do is to align and aim at have a convergence with the current efforts that are working in the Yang push drafts. And what we bring in this for this hackathon is the Kafka integration of these signatures and validation that we have a simple demo that produce some messages that can be young push notifications messages that are produced to a topic, and then we have a consumer topic, a consumer of Kafka that has a sign-in module that it produces it to a sign message topic. Then this has a random alteration of the messages, so we can check that the verification can be invalid or valid, since there are some that are tampered and other that they are not tampered. And what we achieve here is that we demonstrate the reference implementation and the Kafka integration, and we have some progress with the young verification and some talks with the young push group that is working in integrating the schema registry in Kafka that integrates validation of young modules. Thank you.
Thank you. Up next is Logadanen. And your remote? Yeah, there you are.
I think there's another team presenting before us.
Okay, someone in the room? Oh, you will present for the post-quantum open source?
No, they're presenting, I think, about ILNP, the net dev team. Okay.
Okay, but I have a different order. So apparently the data tracker and the meet echo orders differently, or I skipped something. Right. I'm wrong. Sorry. I missed the ILNP. So. Okay. Yeah. There's some doublures also in the meet echo. I will figure out. So. Thanks, Logadan. ILNP. Sorry. No, it's a different order than I thought. Then we have 2 times Yang, 3 times Yang, and then the ITF. Okay, Logadan, you're next, indeed. Thanks.
Yes. Okay, great. Oh, I get nervous now. Okay, identifier locator network protocol. We've been working on this across several hackathons, basically trying to improve the protocol behavior. People here today working on it, and yesterday, Rod Grimes, Alistair Woodman, and myself. And we're grateful for support from the ICANN grant program for being able to be here. Just a reminder of what we're trying to do. We're trying to change the way that IPv6 addressing is used to make it more flexible. So we keep the semantics of the upper 64 bits the same as a prefix. So it's used by routers just as they would. So ILNP packets look like IPv6 packets. We call that a locator, but we change the way the lower 64 bits are used at the end host. So that means making changes to the operating system and tweaking things there so that it's recognized in a different way. We also have very dynamic binding between these identifier values and locator values. And so by changing those bindings, you can do things like multihoming potentially easier than relying on just routing, because you can do it from the end system. So we're really trying to test, can we do this from the end system? We also have some control plane information. So we have a new ICMP message. And again, this is part of the testing to see if the ICMP message can make it across different parts of the network. And that allows a node that's changed its connectivity, has additional prefixes or has prefixes removed to signal to its correspondent nodes that here are my new prefixes. Previously, we've been looking at just basic connectivity to make sure that works between a lab network I have at the university and the hackathon room. And so today was the first time we're trying a domestic link, so a fairly modest broadband link in my home. And I didn't tell my family about this, so I had to keep data rates low, testing to my home on a Saturday evening. Otherwise, they would have been very upset. But anyway, we're using standard IPv6 binaries, so they think they're working over IPv6. So we use IPerf3 just to send some flows, UDP flows and TCP flows. I had a machine set up at home with 4 interfaces, each with a different locator. And I did a sequence of connectivity of turning the interfaces on and off to see what would happen. So this is a kind of outline schematic of the diagram. We've got a server, IPerf server here in the hackathon room, and remotely the client. And it cycles across those various interfaces, turning them on, turning them off, and picking up prefixes. This is what the throughput looks like for UDP. So on the top 4 graphs, you have the individual interfaces and the throughput on those. And on the bottom graph, you have the overall throughput for the end system. So of course, UDP doesn't care too much about what's happening in the rest of the network, so it's fine. TCP, of course, gets a little bit nervous. So as the interfaces go up and down, you do see some perturbation, but the bottom graph shows that on average, at least, the throughput is pretty much the same. We'll be at the Hack Demo Happy Hour if you want to have a chat or if you want to see a live demo. Thank you very much.
Thank you. So next up, Logan. You want to run the slides yourself? Shall I do that?
Can you please do that for us? What we can do faster.
Yep. Okay. Here we go. Just say next, and I will move forward. Yep.
So, yep, we've been focusing a lot on PQC, but not on certificate, but mostly on integration within various open source projects. Please go next. So it's mostly about PQC support, X25519, MLChem-768 hybrid in various CNCF projects. It's the same cycle. We commit, we test, and then it's rinse and repeat. Next. So we got quite surprised that the my new guys pulled this pretty fast. We tested it, and then they also sort of took the patch and just committed it. Open telemetry guy, they're waiting for the next release of Go so that they can commit the PR. And there's this thing called OpenShield, which is like an AI firewall that uses TLS for transport communication. And we also make sure that we have something that actually can do 25519 MLChem-768. So that's what got done in the short amount of time. Next slide, please. Yes, so what we learned, there were some backward compatibility issues as usual, like you have to know the version of a TLS stack that you're updating to, and you might just silently be losing some of the PQC property, and you need to test and verify, and you also need to look at the unit tests and make sure that there's proper code in the unit tests as well in those various CNCF projects. So next, please. So that's the team from Mauritius. We got quite a few first-timers as well from their first-year students, Bavanesh, Sian, Nakul, Kushan, and Mithilesh. We would like to thank everybody who helped us during the hackathon and before, who helped us with the reviews for the PRs, who took time to help us with reviews of PR. The PRs are on our GitHub repository. We would also like to thank Thibaut from Cloudflare as well, who will present some of our other work in next session. And yes, thank you very much, Beno. And if there's anybody from CNCF who can help us with more going forward on PQC, would be happy to talk to them.
Thank you very much for your remote participation, Logan. Thank you. Up next is the NTP working group contribution. David, you're there. And then after that, we have NTP, SCONE. After that, the SCONE presentation. Here you go. That's the wrong one. I uploaded my own. You uploaded your own, and this is the wrong one. Sorry. I will look for another version. Maybe there are multiple versions. NTP. Yeah. That's awkward. Yes. No, I don't see only the.
I can do it without slides.
Yeah?
Yeah.
Or I thought you first wanted to start how HTML to PDF failed, but sorry. Okay, without slides. Sorry.
Yeah, apologies for the slide failure. So from the NTP working group, we worked on 3 main areas. We did some work on NTP v5, which is a recurring theme in the European IETFs over the past few years now. We did some work on NTS pools, which is an effort to get NTS to be adopted more widely. We got a pool running. There's 3 servers in it currently. If there's always interest in more servers. If you're interested in running a time server in with network time security in a pool, come talk to us. We're also at the hack demo with the pool project. And finally, we did some work on PTP/CSP2P in combination with NTS. There's a number of people. I'll make sure that the slides get uploaded at a later date, the corrected versions. And that's pretty much what we did. What we learned for the pool part particularly, we learned that most of the setup work is now reasonably well done. It's fairly easy to set up servers and add them. But there's some limitations around servers that announce their location at a different location than what their key exchange server is. So we need to do some fixes on that. And that's going to be part of the discussion that we're going to have in the working group on Monday morning. So if you're interested in that, come to that. And we're also, again, like I said before, we're going to be with the NTS pool stuff also at the Hack Demo Happy Hour. So if you're interested in that, feel free to visit us. I think that's about it.
Thank you. Thank you for your flexibility, David. Up next, SCONE, and after SCONE, it's IPsec performance. Right, plus NTP, SCONE. This one is.
Thank you. I'm going to activate turbo mode. So SCONE is a pretty new working group at the IETF. This is actually our first hackathon. SCONE is standardizing a quick-based capability to indicate to adaptive bitrate, mostly video applications about network throttling rates within the network. And so importantly for the hackathon, it requires compatibility between clients, servers, and in-network elements. So we had groups of people working on both a number of different in-host quick client server implementations, as well as a number of different in-network elements. And so we were able to actually start some tests to test some of these combinations end to end. And we had a great amount of participation, especially considering this is the first hackathon, and I think the working group only met once in person so far. A number of different companies and the university were represented, and we had some remote participants as well. We were able to succeed even in this early effort in getting transport parameter negotiation working between some implementations. And actually we got more done since we cut the slides. So the story is even better than this. And if you come to the working group meeting on Tuesday, we'll have a little bit more thorough description. But we had multiple client and servers interacting through a network element and SCONE packets and signals traveling end to end. We also managed to get some GitHub issues posted to clarify some things in the protocol spec. So we're strengthening the work in the working group as well. And we found some pseudo SCONEs nearby. And this is just a couple of GitHub issues that we raised about the protocol. And that's it. Give the time back.
Thank you. Thank you for giving me Thank you for helping me with the time management. So up next is indeed the IPsec performance, and then we have the interdomain source validation, address validation, apologies. There we go. Yep.
So hello, I would like to talk about some IPsec performance evaluations that we did to look at the RC 9611, which is basically used for or used to more efficiently use high bandwidth links, for example, for data centers to exchange data in a secure manner. It basically enables the IPsec to create multiple security associations and so to use the hardware in a more efficient way. We were provided with a very nice test bed for this by Paul Wouters and Tatu Ilonen. So we could test a 100 gigabit link or on a 100 gigabit link. And there we learned by using the new latest strong swan version with Linux kernel 6.14 and iPerf and Nepper as a traffic generator and perf for debugging. We looked at 3 different kinds of traffic. First, the unencrypted traffic to create a baseline. Then the encrypted UDP traffic without the per CPU feature using a single IPsec SA. And then the encrypted UDP TCP traffic per CPU feature using different numbers or different amounts of CPUs that were available. And we learned quite a lot. First of all, there was a noticeable performance benefit. However, at that speeds, there were a number of parameters using that influenced the gained benefits and require a lot of fine-tuning. For example, pinning tasks to CPUs and configuring receiver-side scaling, RSS, and driver config, which widely affected the performance gains. And also, we realized that there were a lot of hardware capabilities, like offloading of packets to networking cards, which vary in their which vary in the feature set. So this might also be a lot of consideration or need special consideration. So therefore, it took us longer than expected to produce any results that were useful. But if you want to know more details, maybe you could come to the IPsec ME working group meeting later during the IETF meeting. This is our team. Thank you very much for your time.
Thanks. So, okie-doke. So, interdomain source address validation, and after that, it will be agent protocol security. Yeah.
Hi, everyone. Here is a report about our interdomain source address validation based on AS relationships, RBIF. And as the interdomain source address validation is important, we proposed the RBIF in SAMnet working group, which uses AS relationships to abstract interdomain routing information. And the RBIF has 2 key components, validation router and AS IP prefix mapping server, which brought 2 key points into RBIF implementation. And we will introduce the 2 key points in the later. And we conduct our simulation experiment in JS3 simulation software, and the below is the simulation experiment environment. About the key question we meet in the implementation, that the first is that how to obtain neighboring AS relationships for validation routers. In our design of RBIF system, we use BGP roles to agree on AS relationships when establishing BGP session, so that validation routers can obtain their AS relationships when needed, and querying ASPA objects in RPKI when needed is also feasible, so that we can have alternatives. And in our simulation experiment, we used the modified bird with BGP roles and also use routinator to receive RPKI objects from relying party. The key question too is that how to obtain IP prefixes corresponding to some ASs. The key component is that AIMS, a server, and we use routinator in basic devices as the relying party. In the design of our RBIF system, that we choose the relying party to get RPKI objects from the RPKI regularly, and AIMS is responsible for integrating the array objects from the relying party and generate a mapping from ASNs to IP prefixes. And finally, provides it to validation routers for generating the IP prefix app rules. In our experiment, we install routinator in the basic devices to act as the relying party, and the AIMS function in it to integrate the obtained array objects. And in our simulation experiment, as the image in the right, we found that existing routing security methods like RPKI can provide much support for our RBIF, but modifications are still necessary. And the open question is that we still wonder that are there or will there be solutions more consistent with our RBIF implementations? And that's all. Thank you.
Thank you. Thanks a lot. So up next, yeah, excellent. So we have the agent protocol security, and after that, KEM-based authentication. There we go.
Okay. Hello, everyone. I'm here to present the agent protocol security. So our plan is to design the protocol, design the security aspects for both AI agent-to-agent protocols and agent-to-API protocols. And in this meeting, we focus on the MCP protocol. And in next meeting in Montreal or the future, we will focus on the A2A and ANP protocols. And currently, we identified 4 aspects of security, including identity, authentication, authorization, and privacy. And here is a simple description of MCP. MCP is a protocol between AI agent with APIs. And this is to explain why we need security on the AI agent. The one aspect is the malicious MCP server or the malicious MCP client will cause some severe problems. And the other aspect is from many countries have published their regulations on AI, for example, EU-AI Act. And the regulations will require the AI system to be more secure, trusted, or transparent. And what we achieved in this hackathon, we developed an identity system for MCP. We built an MCP client and MCP server with Python, and we implement a function called identity management, which in short is IDM. And the MCP client and server can apply the identity from the IDM. Currently, our design on identity of AI agent is based on W3C and we add some external parameters specific to AI agents. For example, description is what function can AI agent support, and the protocol is what AI agent protocols is supported by the AI agent, and some transparency information for the AI agent. And here is an example of the message flow. And the second part we achieved is the authorization. So IDM can be like an authorization server, and it can issue some access token to MCP client, which is AI agent. And the MCP client can use this access token to call some tools provided by the MCP server. Also, we use the W3C VC as the scheme of the access token, and we add the name of the VC is attribute credential, and the description is for authorization, and in the subject claim is call tools. And here is a simple message flow. And next, we will implement some A2A security, and in the future, we may implement some security tools to put it on the MCP server. And here is a member list. And any comments, collaboration is welcome. And see you next time in Hackathon.
Very well done. Thank you. So again, the order I see on my Meet Echo is different from the data tracker. So I hope that's not too confusing. After that was the KEM presentation, KEM-based authentication. Is that in the room? Yeah, okay, excellent. And then it's RATS. The RATS endorsement, that's afterwards. I saw in the data trackers the other way around, but it is what it is. There we go. Success.
Hi, I am Lidia Pocero from the Industrial System Institute at Greece, part of the Athena Research Center. Well, our plan for Hackathon was implemented the new authentication method for EDHOC based on KEMs. That is part of the drafts that we will aim to present it in the LA working group agenda on Tuesday. Well, we wanted to extend our previous work that we have with PQC signature based EDHOC with this new KEM-based authentication method. What we sorry, well, sorry. What we done until now, it is open access in a new branch in our repo. We add the new KEM-based test vector with the MLKEM 512. We make the formatting of all the new methods. We generate and process in methods 1 and 2, and we achieve until the point to create the new pseudo-random key that is a combination of an ephemeral KEM series secret and the responder authentication KEM series secret. Well, in our next step, we want to complete the rest of the handshake implementation, test it in Cortex M4 basic constrained devices, and benchmark and compare it, the KEM-based authentication for EDHOC method with the PQC signature authentication method, up of real-world scenarios with, say, syslow-pan networks to measure processing time, memory overhead, and network overhead and power consumption, to come out to see what of this approach will be more efficient in constrained devices and will be better for these kinds of lightweight protocols. Well, thank you. That's all.
Thank you very much. Up next is the RATS endorsement. There we go. And after that, this excellent, great. And after that, we have, according to, yeah. And after the RATS endorsement is benchmarking with network computing. There we go.
Hi, so yeah, RATS endorsement distribution with CoServe and Verizon. What's that about? The context is this. So this is the RATS architecture for remote attestation and the conveyance of endorsements and reference values from their respective providers to the verifier is the context. The problem is simply that the idealized RATS model hides a lot of real-world complexity. We want to avoid fragmentation. We want to avoid a sort of vendor-specific mess. So the objective was to show that CoServe can form the basis of a common endorsement distribution interface for the industry, and CoServe is the draft. So basically, this hackathon is running code for the draft based on the Verizon project. This is what we built. So there's the Verizon service. Verizon is traditionally a RATS verifier, but we've transformed it to be an endorsement distribution endpoint as well. So we've added the endpoint, added plugins, plugins that can talk to Verizon's internal data stores to retrieve artifacts, but we've also shown how proxy plugins can wrap and convert these vendor-specific services as well, based on 2 examples with some test scripts. So basically, we demonstrated that a single common API with a single query language can work across all of those technologies. a few things there that we learned. So it is feasible. We got it working. And on Wednesday, we are going to be taking the CoServe draft into the RATS working group session and make the call for adoption. So just to wrap up, that's the team, myself and Thomas and Yogesh. The artwork there is thanks to Thomas, and we didn't have any yellow coloring for the shoes, so we had to solve that problem with a bit of normative text. It was very much on theme for this week. That's me out of here. Thank you very much.
I like the artwork. Excellent. Okay, yeah, so the benchmarking of networking components, and after that we have, yeah, all right. So, the codec goes the same? Oh, excellent, excellent, great. There you go. Please go ahead. You can use the clicker.
Hello everyone, this is Alejandro from Telefónica and Alex from UC3M, and these are our cats. Please notice there are two different cats, not the same one. And we are presenting work related with the cats, computer-aware traffic steering working group, and a way to aggregate the metrics to enhance the use of this. Okay, the main idea of this challenge, of this work, is to apply a joint exposure of the compute and network capabilities for a better path selection. To do this, we've used the framework of a European project called Codeco that we are going to use for extracting the metrics from both network and compute. Those metrics are the ones that are defined as level 0 metrics and are the raw metrics, the ones without context and without any type of aggregation or modification. Our goal is through this 3 level of aggregation provide adapted and customized view to customize optimization problems, taking decisions with a single scoring obtained from that integration. Please just check that there are 3 levels. The level 1 is an aggregation for thematics, topics, and so on, and the final level is a normalized and aggregated level. And what we did, and what does we learn?
So during the hackathon, what we did is deploy a cluster of Kubernetes that had the Codeco framework inside, which we could use those metrics to implement these levels from CATS framework. So in this cluster, we measured, we had 3 nodes, and we measured the latency, the bandwidth, and then some metrics from the CPU for each link in the cluster. So as a level 0, what we have is an aggregation. The raw data with just the units of the bandwidth would be, for instance, the megabits per second and all that. So then we did a basic aggregation for the results of the level 1, that is like combining the bandwidth and the latency. With just that, we'd have like a basic queue classification for the basic link quality, which we can aggregate to have like the basic node recommendation level of the cluster. So thank you everyone who had the interest to come to our table and for listening to us. Thank you.
Thank you. All right, so now next is, let's see, the Python scrapers authentication. Is that in the room? Yep. And after that is, all right, again, remote attestation with multiple. Okay, and that one, it's half a sentence. But the speaker probably knows that's his or her presentation. There we go.
Okay. Hey everyone. So going to present the small project we did around how do we do scraper authentication, and specifically Python scrapers authentication. Question is, why Python scraper authentication? Because it seems to be like very popular way of scraping the web. The repository which we want to integrate with is crawl4ai or scrapI. Crawl4ai has 50,000 stars on GitHub, a couple of forks, a lot of activities. Question, if it's so easy to scrape the web, it probably should be rather easy to like authenticate yourself when you scrape the web. So we want to integrate with early version of such protocols and interop with like existing implementations in TypeScript. We don't want to integrate with LLM. Once again, we have like 1 day, so it's like a bit too short, but to keep it on the back of your mind. If you go on the next slide, if I can. Okay, so how does a scraper work overall? Because this is interesting. Something we did investigate a bit. You have the user that wants to access example.com. It goes to the scraper. The scraper has a core, which like will orchestrate a bit the activity of the scraper. What we will do is we will build the middleware that like would add like the authentication layer that we want. Then the request that is out of the middleware will go to the browser, and the browser will scrape the website, ideally with like a signature or some sort of authentication. If you go on the next slide, can I go on the next slide? No, maybe, yes, here. I will click.
Okay.
So it's interesting because on my screen, I'm on the next slide, but not on this screen.
Maybe we're disconnected for some reason. No, internet. Yeah, oh, there we go. Yeah, you're right. Okay.
Okay, I will do without, because it seems we have a lot of projects, so we'll continue. So for those who are on Miteco, you can see the slides here, you will listen to me. So what I mentioned before, we wanted to have like the scrapers, and we'll build a middleware. So what we did is we built like a middleware for 2 scrapers in Python. We built an implementation of the package and the authentication. We integrated it with a middleware. We tested the middleware, and the middleware has started to be packaged so it can be integrated with like auto discovery with CoAP. We have a demo, which we won't be able to see. But if we want to see the next step, one thing which has been successful is we managed to do interop with TypeScript. Okay, fantastic. Just one step back. We have a demo. It works. You can check on GitHub. It can run on your local machine, and that's it. We have a successful interoperability. We learned a lot with Python and how it works. We had a lot of new participants and remote folks, which has been great to see. The code is on GitHub, and we have a BOF tomorrow. That's it. Thank you.
Thanks. Okay. All right. We have here. Yeah. The remote attestation, and after that, the SRv6 SFC. Right. There we go. It's the problem of the screen sharing. This seems to. Okay. Let's see if we are still online. Just do it. Maybe. Confirm. Stop slides. Let's see if that works. No. It's really disconnected. Yeah. It worked. Python. Oh, different order again. Let me go here. I thought I saw it. I think we shows the QR code very small, but it's because now sharing, that seems to be okay. And this, and then it disappears probably. No, there's a wrong one, but still it's something. Oh man, there's so many doublerons. This is yours. And then it goes blank, or not blank. It shows logo very, I don't know. I'll go, maybe I will try the next presentation and see what's going on here. No. No, sorry. One moment, please. We get support. This makes sense. This one works, but we already have done this. This one works. Okay. Don't touch it.
So, yeah, this is already So hello, so this is Jun Zhang from Huawei. So our project is on the remote attestation with multiple verifiers. So attestation is the process to ensure that the system works properly. So you see that it does not work properly just now. And so we are working on the motivations that are why we need the multiple verifiers. So it does not move.
No, yeah, there's something. It goes to the next slide on the laptop, but not on screen.
Okay, so I try to.
No, it's fine. There's some lag between this. I can see on the screen that it's right here.
So I'll present without the slides. Maybe yeah, yeah. So in the RATs, actually, so currently RATs architecture only have one verified. So actually, we will see that in some cases the one verify is not sufficient. This is the examples that now when we in our hardware, we have the CPU, we have the GPU, we have the operation systems. And for these vendors, they already have their verification service. So means that there are already multiple verifiers already exist. And we need to find a way to specify how these verifiers should communicate with users and how the information should be sent between the verifiers and how the attesters send information to the verified groups and then get the information back. So these how we will work on these kind of stuff. So because we do not have the slide to see. So welcome to our side meeting on Tuesday, and we'll present our draft in the Friday. Thank you.
Thank you very much.
And you see, we need attestation.
Right. A big hand.
prototypes. To that, I guess you can't see the slides, so I can go through these references. Thanks.
Thanks, Q. Thanks a lot. So up next is, let's see, because the order is, again, the order is different here in my screen than on the data tracker. So next for me is the SRv6. Is that correct? Someone in the room? I think already asked maybe. Then we have had, I think the knowledge graph driven, I already asked, or is that's you? Okay, excellent. Yeah? Okay, excellent. Thank you. Yeah. Yeah, that's not working. So people in the room follow it. Yeah.
Okay. Our Hackathon project is about using knowledge graph to understand the threat intelligence and generate network configurations. So there is a motivating example about the threat intelligence of HTTP rapid reset DDoS attack. For a network operator, when he gets such kind of threat intelligence, he needs to answer two questions. The first question is, which devices or software should I use for the defense? Should I use a router or WAF or firewall or some other devices? The second question is that how should I configure these devices and softwares? So the problem we focus on is that the operators need to learn the intelligence and manually type commands to achieve specific intents. But this would introduce several challenges, including the learning curve and the expert experience requirements, and they also face some risks of typos or fat finger issues. So we propose to use large language model to construct an intelligence knowledge graph and use graph retrieval augmented generation technique to generate the configuration. And we have put the detailed solution workflow in our GitHub repo. We also have the example input and output in our GitHub. The input is threat intelligence about the HTTP rapid reset DDoS attack, including its description and suggested solutions. The output is configurations, including such as keep alive requests or other parameters to collaboratively to facilitate the defense. So we plan to bring some new work to working groups, including the framework of large language model and the knowledge graph in network management. And we also have three drafts related to this topic and the corresponding solutions. Our team members are from Tsinghua University and Beijing Zhongguancun Laboratory, and we thanks all the comments from Hackathon. Thank you.
Many thanks. Right, up next is this one. We have the RPP. So the fast software authenticated, and then the eBPF. Yeah, excellent. There you go.
Hi everyone, this talk is about HIAE, a fast software authentication encryption. So nowadays, encryption and authentication are critical for many IETF projects, and performance need to be fast because the bandwidth and data usage requirements are growing. Recently, ultra-fast ciphers are proposed, but they are typically designed for Intel CPUs. However, ARM CPUs are more popular now in both mobile device and computers. So we propose HiAE, which is a new authentication encryption, which is extremely fast on ARM CPUs and also keeping excellent performance on Intel devices. In this hackathon, we try to evaluate the performance of HiAE on ARM and x86. So we also have our IETF draft. What we already done in this hackathon, we improve our draft to be more comprehensive and friendly to users and implementers. And we also add more implementations in Python, Zig, Rust, and Go also. And the performance of HiAE is improved by 23% compared to the reference implementations. We also have parallel versions for Intel CPUs, which is added also. And we have multi-platform benchmarks, including comparisons with others algorithms like ASIS and ROCAS. So you can see in this figures, we have performance comparisons on Apple M4 and AMD Zen 4. You can see HiAE, which is in pink and red, achieve highest performance. And on AMD Zen 4, it can reach more than 400 gigabit per second. We thank Frank Dennis for leading our team, and you can find out more about our projects in this QR code. Thank you so much.
So thank you very much. It's really difficult to present without the beamer working. So big thanks to all the speakers that improvise and are speaking and presenting their projects right now. Up next is the eBPF. I'm too much in routing nowadays. eBPF. Oh my God, sorry. Apologies here. And after that, we have VCON. There we go. There we go.
Oh, okay. Hello everyone, I'm Li Zhaoxi. Hello everyone, I'm Li Zhaoxi from Tsinghua University. Today I'm presenting a packet SOAP, an eBPF-based tool for analyzing and debugging proto stacks. Packet SOAP is building on 4 functional modules: the tracer, analyzer, locator, and guarder. Let's look at what each one does. First is the tracer. Tracer uses eBPF to trace the path of packet inside the TCP/IP stack, right at the kernel level. It then generates detailed visual path diagrams so you can see exactly how data flow and pinpoint issue like delay or retransmissions. Next, the analyzer provides multi-dimensional statistics on packet flow. You can measure key metrics like interlayer latency, packet loss, and retransmission rate. It also features customized dashboard, allowing to focus on statistics that matter most to you. Locator expand or view to the internet. It shows you the complete route hop by hop, including latency and autonomous system information for each step. You can also visualize the entire path on a world map. Finally, our guarder module focuses on security. It detects threats like off-path attacker and spoof packet at the kernel level. More importantly, it can use LLM like DeepSeek to generate filter rules for identify threat and perform real-time filtering on block those attacks. In summary, PacketSOAP offers a comprehensive toolkit for deep protocol analysis and security. The project is open source on GitHub, and we welcome all pull requests. Thank you.
The VCON. After the VCON presentation, it will be the secure zero touch.
Hi, my name is Dan Petrie, and I'm going to talk about what we did with at the VCON table. There we go. We focused on a couple features that were not implemented previously to try to hash that out and see if there's any issues. We looked at this appended concept of a VCON. Actually, just a quick background. VCON is a data exchange for conversations, whether it be email threads, phone calls, video conferencing, as well as the analysis and metadata related to those conversations. So we looked at this appended concept. When we have a signed VCON, you can't modify it, so we create this concept to be able to create an amended VCON. We looked at some issues related to versioning of the JSON schema versus extensions, and explored that, and had some great help. We have a new Go implementation of VCON that's up and coming. So some great stuff going. Oh, and also. So in terms of participants, we had Rowan May, Chris Wendt, Robert Sliwa, Tom Howe, myself. We had some help with Ori Steele and Michael Jones. And what did we get done? Well, I think we solved the issue with versioning versus extensions. We're going to get rid of versioning and just use extensions so that we don't have this conflicting multi-dimensional problem. I'm sorry, I'm not going to read out a link here for the Go implementation. It doesn't work so well. And we did, there was some interoper testing that we performed. Also, some updated some implementations to the latest version of the internet draft. There was a few changes in the schema and naming of parameters and things like that. And then we managed to implement and test this concept of appended VCONs with working with signed or JWS VCONs. And that's all I have to say.
Right. There we are. So we have now the secure zero touch, and after that, skip. I see. Yeah, there you go. There you go. Let's go.
Hello, this is Giovanni, and I'm talking about today our project on zero-touch association for hundreds of microrobots and using the draft lakeouts or lightweight authorization using EDHOC. So, first, the problem. There's problem number one and problem number two. Problem number one is securely associating or enrolling massive fleets of IoT devices. So imagine, like, for example, in huge industry sites or swarms of tiny robots like this. So how do you securely enroll them? So the draft lightweight authorization over EDHOC allows doing this kind of things. And so problem solution. And then second problem is how do you connect hundreds of tiny robots using a low power network, kind of like what was done in 6-dish, but now with mobility. So you need much more fast response time. So what we did for the solution is what we call a micro robot access radio infrastructure that allows connecting hundreds of micro robots with a very low power network. We have a test bed here, and I will be showing this on the demo hour tomorrow. And the goal of the hackathon was to combine these two things, to combine the lightweight authorization over EDHOC with the network built to connect the hundreds of micro robots. and it kind of worked. So I was able to code a gateway that was my authenticator in the topology of lightweight authorization over ad hoc, and a node. Here I'm showing tens of nodes. In my actual test, I only validated with one, with the security. But it works. So I can send an ad hoc message from one device to one gateway, and then it goes to my server, and then it authorizes the robot to join the network. And it's kind of ongoing work. So still more things to do in the end of the handshake, but it was a great result. Pretty happy with the result. And that's it, basically. If you have questions, approach, and then tomorrow there's the demo. Thank you.
Thanks very much. Skit. And after Skit, validate configure subscription. There you go.
Thank you. So I'm Nicole Bates, and I'm from Microsoft's Azure Office of the CTO. The table here and plus some remote attendees focused our supply chain integrity, transparency, and trust efforts on interoperability and demonstrating an end-to-end workflow for supply chain security. So in order to demonstrate interoperability, we really wanted to produce receipts from multiple independent transparency services for the same signed statement. We then wanted to verify that transparent statement, including the signatures on the signed statement and then the receipts. And then we just wouldn't want to stop there, of course. We wanted to show the end-to-end flow from signing, countersigning, transparency, storage, and then being able to retrieve those artifacts that you just signed. And then, of course, there's a Skit4Fi demo repo here that you can do this on your own. And just to walk through what we did, we took an artifact. In this case, we took our AI model, so the 5-4 reasoning model. You can take any artifact you want. So you can take an SBOM, you can take a firmware deployment, process development. It's kind of a neutral here. But the fact is you take this artifact, you then go ahead and sign it. In our case, we created an in toto statement. It was a model manifest here, a JSON file. We then went ahead and wrapped it with a Cozy Sign 1 wrapper, and we submitted this to our cloud transparency service at Microsoft. That generates a receipt, the first receipt here in this workflow. We then went ahead and took the same signed statement and submitted it to DataTrails transparency service and got a second signed receipt. We then went ahead and stored our artifacts into an OCI container registry. In this case, we use the Azure Container Registry. And so this workflow is available on GitHub. Thank you very much for your time.
Thank you. Right, where are we? Yep. After the validate configured subscription, we have testing congestion control.
Hello, everyone. My name is Ahmed El Hassani. I'm from Swisscom. So today here, was planning to present the validating of Yang Bush publisher implementations that we did in this hackathon, but it's going to be too long. So I'm going to run this presentation as a movie trailer. And like a real movie, I'm going to show at the end the locations and the times and the stars that you need to go in this during this IETF to see the rest of the talk. So I'm just going to run over the highlights here. So what we did is to validate Yang Bush across the entire chain, all the way from the router to the collection to sending out to consumers and Kafka. And the goal here is to validate at every step that we can get the right data and the tooling there works. So we identified some issues with the vendors. Most of them are okay. We identified some issues with the tooling. We addressed some of it and fixed it this hackathon, and some we open bug issues. Hopefully in the next couple of weeks will be fixed. Our test results and our testing tools are open source. You can always check them out. The links are in the slides. This is more for architecture. Now for the implementation status, we noticed at least for MVP1, which is the target we set with in IETF in AMA-MOPS to deliver, are mostly met by all the vendors, the major vendors at least. MVP2 and 3 are on progress. So hopefully by October, we have a more complete implementations. We found some issues with Yang library and how LibYang handles it. So we are reporting this to the LibYang folks to fix it. And we also found some issues with how the vendors are using Yang library in their implementation, and we reported them, and we hopefully in the next release they're going to be fixing it. We also found in lab another bugs here. Also, we are extending our schema registry to allow to enable Yang features in it. So that's something we're going to work in the next couple of weeks. We also have showed the API and validated it completely end to end. And towards the end, we're going to fix some of these issues. We're going to work with the different repositories and the maintainers of this code. Also, we are adding a schema registry support. Now, for the team, so it's a large team. Thank you, everyone who are here. It's too long to list here, but the most important things, see us at NMOps. There is 2 sessions, one on Monday, one on Tuesday. See us on the side meeting. We're going to actually show the code running end to end, and we're going to go through it and more details. And with that, thank you.
Thank you. Excellent. So we have the testing congestion control, and after that, DNS over CoAP. There we go.
Right,
you can use the clicker. Or...
Okay, no problem. Yeah. Hello, everyone. I'm Mohit, and we have a team of 10 students. 5 of the students are here in person, and this is their first IETF, and 5 students participated remotely. We primarily worked on testing congestion control and queue management algorithms. This work is related to CCWG, ICCRG, and TSVWG. Primarily, we had 5 objectives as a part of this hackathon, out of which we could successfully complete 3 of them fully, and 1 was partially completed, and we could not go to the last one because of some problems that we faced. Among the first objective was to compare FQ-Codel, which is RFC 8290, with FQ-Pi, which is an internet draft that we have active right now in TSVWG, and I invite you for the presentation on Wednesday to TSVWG to look at the FQ-Pi draft. And there were a couple of scenarios where we found that FQ-Codel was finding a bit of difficulty in capturing the throughput that was available, particularly when the RTT was varied from 15 milliseconds to 30 milliseconds, and also when the RTT was reduced from 30 milliseconds to 15 milliseconds. The second objective of this particular hackathon was to solve a small bug that we identified in the Codel, which is RFC 8289. I'll be talking more about this in today's hot RFC, and also be discussing about the fix, and we are looking for collaborators. The third objective that we got completed was implementation of RFC 8511 in a simulator called NS3, which is called Alternative Backoff with ECN. We managed to complete it, and the merge request has already been opened, and the reviewers are already taking a look at the code, and we hope to get the code merged. Thank you very much for this opportunity. It was a great experience to be here. Thank you.
It's great to see that many students. So it's thank you. Hi, Martin. Yeah. After this presentation, the next one is EDHOC, EDHOC, ad hoc, probably. I'm very bad at acronyms.
Okay. Hello, everyone. So I basically continued my work from Bangkok, so implementing DNS over CoAP for various platforms. And the plan was to first work on my Unbound implementation on the first day, and then on the second day work on the Fedora shipment of my Python-based DNS proxy that also includes DNS over CoAP. And oh, the check marks are not shown, sadly. But what I've done was to make the OSCOR credentials non-constant and configurable. And the CoAP resource path is now non-constant and configurable. The other stuff is basically a bug in libcoap to find out why it sends piggybacked ACK instead of cons, and then integrate the DTLS part or with the TLS part of Unbound itself. Currently, we are just using libcoap's tiny DTLS integration for that. And that I didn't manage to do yet. And for the second day, I basically worked on this Python library, IODNSprocs. And there I published it to PyPy so that it can be taken from there for the Fedora package, and then also worked on various bug fixes so that it runs stable now and also with the latest Python version and not like Python 3.10. So yeah, it works now. What we've learned with Unbound, there wasn't that much to learn because it was mostly just refactoring of code. So I wrote it on the slide, but yeah. For IODNSprocs, sadly, the implementation status of DTLS in Python is still somewhat shaky. And especially that's true when using it with CoAP. So with OpenDSL, it doesn't export the DTLS in any way or not completely to Python, so you can't use it with CoAP. For WoFSSL, it declares the ciphers that are needed for CoAP actually as insecure, so you can't use that with CoAP. And with tiny DTLS, the Python wrapper is currently maintained by only one single person, and it is very finicky to use and also only supports DTLS 1.2. So it would be nice if someone had like maybe a hackathon project for next year or next time to support DTLS 1.3 for an embedded system. That would be great. And yeah, as a wrap up, these are the team members. Martin, Benson, and Christian helped me with IODNSprocs. And if you want to contact me, you find my email address on the slides. Sadly not here, but in the Meet Echo.
Thank you very much. Thank you. So next one is the ad hoc presentation. Yeah, okay, excellent. So we're clearly running over time. I think given the number of presentations, about 30 minutes. So it's partly technical issues, also partly because we have a lot of presentations, more than we expected. So please bear with us. And I'm also wasting time, of course. Sorry for that. The list becomes longer and longer. This is not there. And here on my list, the next one is. Oh, this is really okay. My list. The next one is secure hybrid networks. There we go.
Hello, everyone. My name is Elsa Lopez, and I'm a PhD student at INRIA, Paris. And today I will be presenting the work that we've been doing with the interoperability testing of EDHOC PSK in collaboration with Francisco López Gómez from the University of Murcia. Okay, so, well, a bit of context. EDHOC stands for Ephemeral Diffie-Hellman over COSI, and it's a lightweight authentication key exchange for constrained devices. So in particular, we are working on the standardization of the PSK authentication mechanism, which you can find in the draft. So for the interoperability testing, we've been working with two implementations, one from the University of Murcia, which is a C code-based on UScore and EDHOC, and the INRIA implementation, which is a Rust code implementation. The tests that we've done were running on the computer, but for simplicity, but it's also possible to work on constrained devices. So the results, the work that we've been doing was, first of all, updating both implementations to the last version of the draft, which is number 4. Then we also found some inconsistencies regarding the definition and the name given to the credential, so whether we need to use the full credential or just the raw key value. So that was also something that will need to be updated. And then we also made sure that both implementations were compliant with the RFC 9668, which defines how to run EDHOC over CoAP. So the results, good result is that we managed to run the interoperability test, but we found some problems, as I mentioned, regarding the credentials, which mean that we need to update the draft and therefore like run another interoperability test with the new versions. And yes, that's yeah. So here you can see like how we managed to run both the handshake in both directions. So each of the implementations running as either a responder or as an initiator. And then, yeah, regarding the credentials, there were some later discussions, and we will need to update the draft. So that means that we will have two different credentials for each of the roles. So one credential for the initiator, one for the responder. They will both have the same raw key material, and then there will be a single ID cred PSK, which is an identifier for both credentials. And that's it.
Thank you. Thank you. There we are at secure, and then we have the large language model driven. There we go. Yep.
Okay, getting tired. I'm Iragawa from ASD Japan. Very shortly talking about the secure hybrid network monitoring. So we have currently some issues on using hybrid clouds or hybrid networks because using several multiple instances of networks connected by some interconnected parties. So in such cases, there are some hidden security assumptions for those interconnections, which should be checked and ensured about the compliance. So we are designing the monitoring solution for the such security properties of communication parties by gathering network statuses using existing telemetry things. So, and summarizing that and exchange between operators and checking for policy satisfaction. So our design principle is that we really want no changes to existing network devices. So we are adding or add-on sidecar implementations to monitoring telemetry layers, which are mostly existing. And we are making a very simple API designs for service exchanges. And we also consider several network restrictions or implementations. So in this hackathon, we restructured the existing draft, and we are now depending on the network telemetry framework, RFC 9232. And discussing about the service implementation architecture. So we will submit a new draft possibly within this week. So if you have interest, please contact these three people. Thank you very much.
Thank you. I just heard that the slides do work actually in the overflow room, but just you know. But no, don't leave me. I would stand here in an empty room. Don't do that. Go the large language models, and then we have after that we have the post-quantum crypto in X509 certificates.
Okay, hello everyone. Our project is large language model-driven automated network protocol testing. And okay, our motivation is that in the past, when the network engineers wanted to verify whether a network device implementation complied with an RFC standard, they needed to first read and understand an RFC standard. They needed to write several textual test cases, and then they need to write the test scripts like codes or CLI commands based on these test cases. This process relied entirely on manual effort and experience, typically consuming significant time and resources with a steep learning curve, primarily due to complex and verbose specifications like RFC documents and the labor-intensive customized test codes deployment, relying on manual API calls and device documentation. So thanks to the recent LM techniques, we try to explore whether these advances that could be applied to automate protocol testing, which may promise to save network test engineers substantial time and potentially enable faster creation of more high-quality test cases and test codes. So therefore, we designed our net test LM, which is a system which is an end-to-end LM-powered automated protocol testing framework containing of the test case generation module and the test script generation module. And an example of the OSPF hello interval field shows our system's workflow. First, our system will automatically process the RFC to extract constraints for the hello interval field, and then converts them into the test cases, and finally generate test codes for validation. Besides, during the IETF, we will present related work at the hot RFC and NRW. So we also have relevant drafts submitted to the BMRG and the MRG. So finally, we sincerely welcome your interest and feedback on our work. Thanks.
Thank you. Yeah. So, yeah, the room is a little bit has some acoustic challenges, let's put it that way. So I do hear many voices in the back of the room, and maybe it's just around the corner, I'm not sure. But please keep that in your mind. All righty. Okay, yeah, excellent. Yeah, thank you. Thank you for... Okay, after this presentation, we will have the FRET, low power IPv6 model. Thank you.
Hi, everyone. Thank you for your patience. So I'll be talking to you about the PQNX509 project. We've been doing this project for about 3 years now, since London in 2022. So essentially, a bunch of us got together and said, let's play with these new PQ algorithms that are coming in the X509 realm. So most of us are actually from the LAMPS working group. So we work with a lot of the drafts in that group, and of course that's the whole certificates thing, and just interacting with these different PQ algorithms, how they work, and gaining experience, also providing feedback in a lot of cases to the standards that we gain from implementation experience. So that's kind of the project. So this time what got done, so we did the projects, I said it's been on the go for a couple of years now. So we did a bunch of general maintenance stuff in the repository. So we have an OID list. So we did some maintenance on that to the latest drafts. We clarified wording on the artifacts because we did have some new people join. And of course they're reading, the information there, and maybe it wasn't clear. So we tried to clean that up. And we also removed the Open Quantum Safe project as an automated verifier because in some algorithm cases it's a little bit behind, and that was causing a lot of our test matrix results to be kind of skewed a bit. So that got removed. We still have 2 automated verifiers, 7th Sense AI and Bouncy Castle as well have that in there. And we had lots of discussions on the composite key formats. So we're trying to work on implementations of the composite signatures and KEM drafts. And if you know about the LAMPS group, there's been lots of discussion on that key format. So that continues. And so what else got done? I had mentioned, so people continue to join the project. We've had about 50 people join now. So 7th Sense AI added some new artifacts. So when people add artifacts, they don't just add them to the repository. There's automation that happens, but also they test everyone else that's in there as well. So that's been going on with all of these. So I'm probably not going to get to mention everyone in this list, but Safe Logic. So Alex joined the group as well this time. Crypto4a, CHT, Red Hound was Carl Wallace, CryptoNext, Daniel Van Geest. So a lot of new artifacts and things were added. It's great to see that, new implementations. So what we learned, so a lot of the people were focused on implementing composite keys this time. So we learned the latest version 07. It was very straightforward for the key formats, and actually people that had implemented them previously in older versions, they found it easier now. And many crypto libraries still do not have the seed format. So I have some pictures of compatibility matrix results. My time is almost up. I'll be talking more about these at PQuip tomorrow, so you can come see that. And yeah, in summary, we've had lots of team members. Our next meeting, we have monthly meetings, is on Tuesday, September 9th. So come join us. Thanks.
Thank you. Yeah. I really want to ask the people a little bit lower their voice because it's really noisy here. So it's, again, there's some acoustic challenges here. Okay, the thread. And then after that we have, I think, Kira, but I'm not sure. Double check. Yeah, after that is Kira. There you go. Success.
So hi everyone, my name is Francois, and this weekend with our teammates we worked on Thread. So for those who don't know what Thread is a low power IPv6 mesh protocol. That means that you can have IoT devices that have an IPv6 address and that can be reached by your other devices on your Wi-Fi. And so they can reach the devices from the Wi-Fi to the Thread mesh using a Thread border router. So Thread is a mesh protocol. It operates at the low bit rate so that the devices can save a lot of energy by being sleepy most of the time. And that allows to save a lot of power. So for this weekend, we had 5 participants in the hackathon. Hermin worked on developing a Thread border router. Myself, I worked on enhancing simulation in Thread. And we have also a team of PhD students that worked on waking up the Wi-Fi interface through the Thread interface to save more energy. So let me dive into that to show what their project is related to energy consumption with Thread. So usually they start from the fact that when you download something on the Wi-Fi, your connection to the internet is often slower than your connection on your home network. And a slower connection means you will have to keep your interface on for a longer amount of time. So what they explore is to, instead of, when you have a battery-powered device, instead of doing the download in the internet, you delegate the connection to another device that will do the download for you on the internet. During that time, you can turn off the Wi-Fi interface. Once the download is finished, the laptop can send some data on the Thread interface of the battery-operated device to wake up the Wi-Fi interface. So thanks to that, the Raspberry Pi here will be able to be sleepy and turn off completely its Wi-Fi interface and save more energy. Then when it's turned its Wi-Fi interface up again, it can finally download the data that was downloaded by the laptop at a higher bitrate. Higher bitrate means it would have to keep the Wi-Fi interface up for a smaller amount of time and save battery. So they implemented that and they made some experiments and they were able to show that with preliminary results, they were able to spare 50% of energy on the Wi-Fi chip just by turning it off during the internet download. And so these are interesting preliminary results, and you can meet us at the hack demo session tomorrow if you want to know more and speak with the students. Thank you very much.
Okay. So up next is Kira, and after Kira, we will have update ASPA support. That's the next after this one.
Yeah, hello, my name is Roland, and I did a little bit hacking together with Julius on the Kira. Kira is basically a scalable zero-touch routing protocol, and we have an implementation in Rust. There's an internet draft, and it is basically ID-based routing that uses path IDs for forwarding and provides IPv6 connectivity without any configuration between a high number of nodes, could be hundreds of thousands actually. We are doing testing in Nest and also ContainerNet, and the goal for that hackathon was to do further debugging for forwarding table inconsistencies that the implementation currently has. And we wanted also to add support for web-based demo with Nest. Since we have already a web-based demo for ContainerNet, which is quite nice, you also want to have that with a more lightweight Nest. And also what we did is, so we did some initial code for the Nest web interface, but that wasn't finished during this hackathon. We fixed some bugs using open telemetry and Jaeger, which is quite nice if you have distributed system and want to track down what's going on inside the different nodes. And Julius also wrote a ReesMonkey script to substitute the random node IDs that we have that are a little bit inconvenient for debugging with the topology-based IDs, so that I can see that that was node 42 or so that did the thing. Okay, and with that, thanks to Julius, who supported me remotely. It was his first IETF hackathons. And next steps is that we also need to align the wire encoding to the latest draft version. And there will be a site meeting on Wednesday at 4 p.m. Kira, you find it on the Trello board. Yeah, thanks. That's it.
Thanks. Right, so where are we here? We have the update ASPA support. Yes, excellent. And after that, okay, the RFC 6725 rule. Okay, there we go.
The other room does. They see it. Okay. Yeah. Hello, everyone. We were working on the ASPA support in the RTRlib. So I will skip a few slides here, but ASPA in general is a router protocol which enables route leak detection. And here. And the RTRlib supports now the ASPA protocol using the RPKI to router protocol. And the current release version doesn't support ASPA, but the master version did support a few of the features. And what we did in the last few days here was checking the differences between previous draft versions and the current draft version, especially for the RPKI to router protocol. And yeah, we discovered that the ASPA PDU changed a little bit. There's more strict error handling. Many checks on inputs are changed or needed to be done. And in addition to implementing that to the RTRlib, we added some corner cases for testing. Yeah. Also, we tested the RTRlib with the Routinator cache server. This was successful so far. So the good news is we plan to have a new RTRlib version in about a week, including a migration guide. And I guess that's it from our side.
Thank you very much. Thank you. Thank you very much. Okay, next up. There we go. Oh, no. it's showing. Ah, there you are. Yeah. And after this presentation will be the DNS presentation. All right. There you go.
So Jen and I did a bunch of testing for RFC 6724. There's a typo in the title. Sorry about that. This basically involved throwing random router advertisements at different client operating systems and seeing what comes out of that. Yeah, okay, that was one too far. This is the results table that we ended up with. You can see macOS and Windows are actually pretty okay. All the Linux variants are rather shitty. That's kind of matches our expectations. We're looking into some of the details. But all in all, this actually looks better than we expected. These are the actual takeaways from the testing that we ended up with. We finally have a confirmation that Windows supports this and doesn't just, we just didn't know. We found a few, well, bug-like things, I would say. We're still investigating that. Need to talk to some people. We also don't understand how neighbor unreachability detection works on Linux. Weirdly, I don't know. And looked at what the 5.5 patch for Linux actually does, and it seems to work reasonably well. All in all, the summary is there is actually support for Rule 5.5 in a wide spread of client systems. So it might be usable to get things into a better state. And this will be presented in a bit more detail on Tuesday in the 6-man session. And that's it.
Thank you. So, thanks. So I just heard that the problem with the projector is a network problem. So what does that say? So probably, if I could make a guess, it's probably the DNS. So speaking of which, Willem, it's always the DNS. Right, and I have to look for it. And after the DNS, it's the SDF model presentation. There you go. Willem.
Yes, so this is a collection of DNS projects that we worked on. I worked on Poisonlicious, which is a new draft. It will be presented Friday at DNSOP. And the idea is that a set of mutually trusting caching recursive resolvers synchronize their cache as follows. If a resolver queries for something and it doesn't, or is being queried, and it doesn't have this response in cache yet, before it puts the response in cache, it also sends it to the other resolvers that then also put it in cache. So it sends a T6 signed, for example. That's really good for POPs of any casted resolvers, for example, to keep all caches hot, less traffic to the auth, so it's also greener. With export, it's possible, also a mechanism to fill cold caches quickly. So Schumann worked on generalized notify. It's a way in which child domains signal the registry that their CDS or CDS key or NS resource record has changed. So it's using notify to signal these kind of things. And he has an implementation in Python. Then Mark Andrews implemented since the last hackathon in Bangkok private OID for DS, for the private algorithm to match how that is handled in DNS keys. He also implemented deprecated notifications in bind for the SHA-1-based DNSsec algorithms. And he worked on only generating within a certain range key tags for DNS keys, so for multi DNSsec deployments. Then some people worked on DELEC, Dick Franks provided remotely a new version of the NetDNS Perl library with a fully functioning DELEC module. Shane Kerr worked on DELEC for NS1 using DELEC-enabled LDNS. And then we have opportunistic transport signaling from Johan Stemstam. So he puts, if the child NS set is in the authority section, besides the addresses in the additional section, there's also a SVCB record signaling if the authoritative supports .doc or .do. And that's it. There are much more projects, but this is selection. I'll keep the slides updated. Thanks.
Thank you. Thank you, Willem. So, yep. And right, we are here, SDF model. And then we have the post-quantum DNSsec implementations. Oh, what? Oh, I have two versions. I'll take the last one. Yeah, I have the 01. Oh, yeah, yeah. Let's get them. Yeah, okay.
Does it work? Or why? Oh, it still doesn't work, right?
This
Okay.
is correct.
Yeah.
And the room is correct.
Yeah, okay.
And everybody has a laptop.
Yeah. Sure. Hey everyone. The project that we are working on is the SDF model-based IoT gateway using ASDF and NIPSI. So the hackathon plan, so our project involved mainly 3 drafts. There's the ASDF NIPSI draft, ASDF SDF, and SCIM device model. So the couple of things that we had planned for this hackathon was to, so first of all, to review and solve issues in the ASDF NIPSI draft. And the second sort of bigger goal that we had was to work on the interop with the open source and vendor implementations that we have for the IoT gateway that uses these 3 drafts. So this is sort of like the IoT gateway interop setup that we have for the hackathon. Yeah, since the slides don't work, I just brought some props with me. We use these off-the-shelf BLE dev kits for our IoT device. And we had sort of 3 different gateway implementations for the IoT gateway. So the first one is we had ESP32 based IoT gateway from the Ericsson research team. Then we had one on the that runs on the Cisco access points. And then we had a third sort of open source version of the NIPSI and ASDF gateway that runs on like a commodity Raspberry Pi with like a BLE dev kit. And then we have like an open source sample control application that we can use to control the devices. And we got it working such that we can use any of the gateways, and it works well with the open source as well as the vendor specific implementations. So what did we get done and what we learned from this sort of hackathon? So the first thing is we were able to expand the scope of the applicability of NIPSI. So NIPSI was mainly meant to be for non-IP device control, but in this hackathon we sort of figured that we can probably extend it for IP devices as well. The second thing was improvement on SDF extensions with the NIPSI specification. So we made some improvements on how we embed the NIPSI protocol mapping in the SDF models. We also worked on defining the NIPSI problem types using the or based on the RFC 9457. We also filed and solved like around like 27 or 26 issues on GitHub, and mostly solved most of them, or yeah, we solved them during the hackathon yesterday and today. We also worked on new tooling for the SDF models with the NIPSI mapping. Finally, just to wrap up, these were the team members that we had for this hackathon, and I just want to point out 2 of the new members that we had for this hackathon. Yeah. Thank you.
Thank you very much. Thank you. Thanks a lot. So next up is the post-quantum crypto cryptography for DNSsec, and then improving the RPKI repo. Let's see. Oh, almost there. Yeah. Joe, please go ahead.
All right. Thank you very much. For our hackathon topic, we were looking at PQC in DNSsec, and we had a good group of people here. We had Andre and Javier from University of Madrid, was I think their first time here. We had Andre from ISC, myself and Swapnil from VeriSign, and Willem from InnoNet Labs working together. So it was a good cross-functional team. We've been working on this for a while. We started back at IETF 118 working on some of these topics. So it's been a good set of projects so far. And the main thing we got done this time is we had an update to some of our libraries for MTL mode. We had an update to bind to get key generation, signature, and validation. And we also had a new name server implementation, core DNS, that got updated to also do MTL mode. So we were able to put in the new algorithms into several places and get some services running. We have NSD running at pq.verisignlabs.com with these algorithms as well. So next steps, Thursday, the 24th is the PQ DNSsec side meeting. So come on out and learn more about some of the other research going on PQ DNSsec. Thank you.
Thank you. So now the RPKI repository, and after that is the green framework, the green project. Yeah, green.
Hello. I believe that everyone in the room loves RPKI repository things. Improving RPKI repository efficiency and practices. Thank you. RRDP is a protocol to deliver the RPKI object to the clients. Basically, the snapshot is the whole set to deliver to the clients, and delta is the delta, the differences between the previous one and the next one. So we as the repository operator or the users would think the efficiency of the transfer whole objects. Then we hacked some data analysis and the measurements in a while. The first one is for more efficient delivery, and the second one for the looking at the best practice for repository operations. So we did many aspects from the many aspects analysis, but we found that the client behavior is more important part for the traffic growth factors than hackathon results. From log analysis, we found that the largest cause of the traffic, it's a kind of frequent downloader. And the second one is the more accuracy of the data set for delivery. And the last part is the implementations to looking at the many repositories in the world. Thank you.
Thank you. Thank you very much, Taiji. Up next, the green framework, and after that, we have the presentation from the, let's see, where are we? The table snoop project. Okay, there you go.
I pass it with this one, right?
Yeah.
Good.
Well, for those of you that are not sleeping siesta, right? I would like you to look at least at that screen there. You have seen a video going on. That video is a setup that Huawei and Telefonica has been creating for this Exigence project. We are measuring service level energy consumption on the service level. And in order to measure service level, you need to correlate that information as well with the different domains from that flow. That flow are passing not only the 5G that you have there in the setup, but as well the fixed network. And we have been trying in this hackathon to analyze each piece of that measurements. And one of the focus of our objectives as well on what we have been trying to address is to demonstrate the meaning of the green framework that we are trying to include in the green working group. The green framework is important and you need to measure in order to optimize. That was one of the main goals for the green working group. The measurements that we are defining, there is a meaning for optimization, and there is a granularity as well as aggregation that we need to do on those measurements. But there are important challenges like a double counting. We are using smart plugs and smart PDUs access through API, where we have been also defining those YAN data models. Huawei has been doing that. And we have been using different tools to showcase. You will be able to see that from the slides. There are important things to notice. We don't have only this API access, but we have been using toolings, reading directly from the smart PDUs, from the smart plugs, and as well from the device, in order to understand that it's not only important the sensors measurements, but as well the load that is the cards that are loaded in the devices, and as well what is connected to the different ports in the line cards. And this is important to understand in order to create those base level and the usage of those devices. Thank you.
Okay. There we are. The table snoop, and after that, the Yang data model for network testing.
Thank you. You're welcome. Thank you. The table snoop is basically a small tracing tool for Linux. It doesn't working with other operating systems or switches. It's for Linux only. It can do live tracing of routing table lookups v6 and v4, policy, or as Linux call it, IP rule lookups, v4 and v6. And the subject of this hackathon was implementing SRv6, basic SRv6 support. It's network namespace aware. That means you can use it with Kubernetes and Docker containers, and it's open source. Here you can see, if you follow the stream, an example output of the tool. This is how it looks like. Basically, it shows the network namespace, the routing lookup, and the result of the routing lookup. For example, the next hop gateway IP address and the egress interface. And if we zoom in, here is what implemented in this hackathon. Basically, if SRv6 and behavior executed on the host, it will show you the action, the type of the action, and some other arguments. It's quite humble in this phase, but it will be extended further. Thank you very much.
Okay. We have now the Jam data model. I have several copies, but all with 0. Okay, I'll just pick one. Maybe, I hope it's the same version. Yeah, yeah. And after that, we have CBOR presentation. Okay. Please go ahead.
Okay, so I start with this tacky slide so that I can get people who haven't heard about this or should have heard about this but didn't. It's a young model for management of network testers. And by network testers, I mean a stateless test device that has a traffic generator and a traffic analyzer. And here on this slide, I have a bunch of them. And like the question is, 2 of these 5 testers have standard-based management interface and protocols. And these are the ones that actually implement the draft that we are working with the benchmarking working group. The draft has been worked for 6 years. We started the work 9 years ago. And it is ready for a work group last call on Monday. So this is the description of the project from the Hackathon wiki. I have copied it without changing anything. We worked on the implementation. We have a working RFC 2544 benchmark test in Python, which is the only open source implementation of RFC 2544 benchmark test. All the components of the project are listed here with links, so those who are interested in the details can check them out. State of the draft, it's been stable for several years. The last change was just changing a name of an interface. In an example, we're aiming for a work group last call on Monday. State of the implementation, full support of single stream traffic generator capability, first open source RFC 2544 implementation in Python, both static and dynamic test frames. So it's a complex project. I don't have the time now to discuss all the components of that, but I'll just provide this image of our test setup, which was blinking and attracted a lot of people who contributed with suggestions. This is how you configure traffic. That's just a slide so that you have more context to think about how you configure something. Like, how do you send 1,064 octet packets with the minimal interframe gap or Ethernet interface? This is how. And the test cases can get much more complicated. Like, how do you send 1 billion packets with packet with the bad CRC every 1 million packets? So this is something that gives you a perspective of what you can use the model to. And the last slide, this is like the multi-stream mode, which we have started working on in implementation. And here we have added significant progress. This is like a multi-stream mode is required when you have packets of different size that you want to send with the same sequence number and PRBS sequence so that you can follow even if the packets are different. So it's like, so that's how how much I managed to put in that time slot. Thank you for the attention.
Thank you. Thank you. Okay, so thank you, and thank you for everyone in the room. We have 2 presentations to go before we close. The CBOR presentation, yeah, over there. Yeah, it's up to you. And the last one is the SCID Nubo presentation, somewhere here on the table. The CBOR first, yeah. Sorry?
It will be presented remotely.
Oh, okay. Let's go.
So they are there online.
Yeah, they're online. Okay.
Yeah, he's there.
Yeah, I'm not sure if. Well, can you speak up? Let's see if we can hear you. Yeah. Can you try? We won't hear you. We can't hear you.
Hello. Yeah. Yeah. I think this is better, right?
Yeah. Oh, okay. Excellent.
Cool. Yeah. 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 Hi, everyone. I'm Siddharth, and we're a group of undergraduate students from the National Institute of Technology, Karnataka in India. So our project during this presentation was adding CBOS support to LibYang. So the motivation behind this was when we were implementing the HTTPS notif draft for Yang notifications by Mahesh and Kent, and also while implementing our own draft, which extended the previous draft, we noticed a lack of CBOS support in popular Yang tooling libraries like BibYang and Yangson. And Thomas Graf and their team also brought this to our attention during their work on implementations of the Yang push publishers. So because of this, we decided to fill this critical gap. Can we go to the next slide? Yeah, thank you. So our goal for the hackathon was to extend LibYang, write a CBOR, complete CBOR support by serializing and passing all the data and printing the data as well. LibYang is a Yang data modeling language parser and toolkit supporting XML and JSON only as of now, and our job was to add CBOR to this. Next slide. Yeah, thank you. So what we did is understood the existing data parsers for XML and JSON, and we decided to work parallelly by implementing one methodology was to use another library called libcbor, which acted as the low-level CBOR parser, after which we could decide to serialize the data according to the requirement. Or else the other method we decided was to write a parser from scratch, taking inspiration from the JSON parser in CBOR itself. I think Meher will talk about the progress we did during the hackathon.
Yeah. So as Siddharth mentioned, we worked on 2 implementations parallelly. The first, we made much more progress while using the libcbor parser, for which we had to sort of make sure, propagate the data length and make sure both the data formats are consistent, and convert the output of libcbor to be consistent with the LibYang's data trees. We compiled all the results, and we'd also written functions and made context structures parallel to that of parser_JSON files to keep it consistent with the LibYang JSON parser. Can we move to the next slide? Yeah. We learned a lot. We'd actually spent a lot of time delving into LibYang and understanding how the library works, and we'd spend a lot of time focusing on this stack calls, understanding the workflow, and also studying CBOR for implementing the low-level parser ourselves. Can we go to the next slide? We have a draft work which is not complete, and the future work we plan to do is we were able to achieve data parsing. We still have to achieve validation and printing the logic. For now, we focused on CBOR named identifiers. We plan to extend it to CBOR schema identifiers as well, and also complete the low-level parser implementation. Next slide. Yep. Yeah, thank you so much. We'd also like to thank Mohit Pitalyani sir for the guidance, and Thomas Graf and the team for helping us out throughout this time. Yeah, thank you.
Thank you. Thank you. Okay, so before I close, did I miss a presentation? Because there was a long list, and no presentation skipped. Excellent. Okay, so Yogesh wanted to express his gratitude. We showed the link to his draft for an hour on the on the screen. Before we close, I would like to ask everyone to sign up for the Hack Demo Happy Hour tomorrow at 7 to 8. It's a great way to show your work, your project to the wider IETF community. And also, I would like to thank our sponsors. Sorry, Ericsson, the gold sponsor for running code, CNIC and ICANN. with these sponsors, we can organize the hackathon 2 days. 500 people sign up. I think we've seen more than 400 maybe through the two days. It was really great. A lot of food, a lot of good coding and good conversations. So thank you for our sponsors. Yeah. And yeah, hope to see you through the week over here. If you think things can be run better, just send us an email to the hackathon chairs, or tap me on the shoulder, or Charles, and give suggestions. We're always open for improvements. Thanks.